Hello, in this lecture I'll answer two questions. In the first question, we find out the radius of this circle, and in the second question, we will find out the area of this semicircle. So let's start with the first question. The drawing a circle. This is line segment CP. This is equals to 12 units in its length. This is line segment AP. This is equals to 4 units in its length. This is line segment PB. This is equals to 4 units in its length. This is angle CPB. This is equals to 60 degrees inside. Again, our task is to find out the radius of this circle. So first of all, it is given us the question that AB is a straight line. So if we focus on the upper side of the straight line AB at point P, here the sum of the areas must be equal to 180 degrees according to all three. So which angles we have at the upper side of the straight line AB at point P? We have this angle, this equals to 60 degrees inside, plus this missing angle. We told them the sum of those two angles must be equal to 180 degrees according to all three. Therefore, this missing angle must be equal to 120 degrees in its size. In the next step, we will join points C and B together by straight line. And we join points C and A together by straight line. By doing those constructions, we created three triangles. This is the first triangle, ACP. This is the green triangle ACP. The second triangle is the white triangle CPB. And we have the big triangle ABC that consists of those two smaller triangles. So in the first step, we will implement the law of cosines on all those two triangles, on all those three triangles. So a quick quickly on the law of cosines. The law of cosines is true in any triangle. This is triangle ABC, that could be any triangle. Side AB equals to 2 units in its length, side AC equals to 2 units in its length, side BC equals to 3 units in its length. This is angle BAC, that equals to theta according to our definition. So in this triangle ABC that could be any triangle, the following equation is to C square equals to A square plus B square minus 2 times A times B times cosine theta. Again, C square equals to A square plus B square minus 2 times A times B times cosine theta. So you can actually implement the law of cosines. Or in the first step, we will implement the law of cosines on this great triangle, triangle CAP. So according to the law of cosines, in this great triangle CAP, the following equation is true. We show angle theta as angle APC that equals to 120 degrees in its side. So according to the law of cosines, in this triangle CAP, CA square equals to AP square plus PC square minus 2 times AP times PC times cosine 120 degrees. And again, in this case, I get ACP according to the law of cosines. The following equation is true. CA square equals to AP square plus BC square minus 2 times AP times BC times cosine 120 degrees. CA is the missing side, so we leave it as it is. So CA square equals to AP square. AP is 3, therefore AP square is 3 squared, this is 9. Plus PC square. PC is 12, therefore PC square is 12 squared, this is 144. Minus 2 times AP is 3, times PC is 12, times cosine 120 degrees. Cosine 120 degrees is equal to minus 1/2. So in total, if you order that according to the law of cosines, in the ring triangle CAP, the following equation is true. CA square equals to 9 plus 144 is 153. Here we have minus times minus is plus, so this expression is a positive expression. And we have 2 in the numerator, 2 in the denominator, so 2 get cancelled. After cancel 2, this expression in total equals to 3 times 12, that is 36. This is plus 36. So in total, we should know that CA square equals to 153 plus 36, that is 189. CA square equals to 189. So here, we take out all of this equation, and we get that CA equals to the square root of 189 units in Islam. CA equals to the square root of 189 units in Islam. So actually, this is the missing side CA is equals to the square root of 189 units in Islam. Likewise, we will implement the law of cosines on this right triangle, triangle CPB. The right triangle CPB, according to the law of cosines, if we choose angle theta as 60 degrees, then the following equation will be true. CB square equals to PB square plus CP square minus 2 times PB times PC times cosine 60 degrees. Repeat again. In this right triangle CPB, according to the law of cosines, the following equation is true. CB square equals to PB square plus CP square minus 2 times PB times PC times cosine 60 degrees. So CB is the missing side, so we leave it as it is, so it is CB square equals to PB square. PB is 4, therefore PB square is 4 squared, that is 16, plus Cp squared. Cp is 12, therefore Cp squared is 12 squared, that is 144. Minus 2 times Pb is 4 times Pc is 12 times cosine 60 degrees. Cosine 60 degrees is 1 half. So to that we should find out that Cb squared equals to 16 plus 144 is 160. And we have here 2 in the numerator, 2 in the denominator, so 2 will get cancelled. After cancel 2, we left only with minus 4 times 12, that is minus 48. 160 minus 48 is 112. So in total we found out that Cb squared equals to 112. So here we take a root out of this equation. If I get that Cb equals to the square root of 112 units in its length. This is the missing side Cb, that is equals to the square root of 112 units in its length. The next step, we define this angle BAC as alpha. And we will implement the law of cosines on this big triangle triangle ABC. We will choose angle theta as angle BAC is equals to alpha. So in the big triangle ABC, according to the law of cosines, the following equation is true. Cb squared equals to Ca squared plus AB squared minus 2 times Ca times AB times cosine alpha. And again, on this triangle, big triangle ABC, according to the law of cosines, the following equation is true. Cb squared equals to Ca squared plus AB squared minus 2 times Ca times AB times cosine alpha. We already found out that Cb squared equals to 112. And it equals to Ca squared. Ca squared equals to 189 plus AB squared. AB in total equals to AP, that is 4. AB in total equals to AP, that is 3, plus PB, that is 4. So in total, AB equals to 3 plus 4, that is 7. So AB equals to 7, and therefore AB squared equals to 7 squared, that is 49. Minus 2 times AC, or CA is equal to 189 times AB. AB equals to 7 times cosine alpha. So in total, according to the law of cosines, we actually found out that 112 equals to 189 plus 49 is 138. Here we have minus 2 minus 7 is minus 14. So in total this expression equals to minus 14 times the square root of 189 times cosine alpha. So in total we have found out that 112 equals to 138 minus 14 times the square root of 189 times cosine alpha. Here we will subtract 112 from this equation. So after subtracting 112 in this side of the equation we left with nothing, that is to say 0. While on the other side of the equation, let's see, 238. 189 plus 49 is 238. So on the other side of the equation we have 238 minus 112 is 126. Minus 14 times square root of 189 times cosine alpha. So here we will add 14 times square root of 14 times square root of 189 times cosine alpha to this equation. That is to say we move this expression to the left side of the equation and we get that 14 times square root of 189 times cosine alpha equals to 126. So here we divide this equation by 14. So here 14 we get cancelled and we left only with square root of 189 times cosine alpha. While on the other side of the equation we have 126 over 14 is 9. So in total we found out that the square root of 189 times cosine alpha equals to 9. So here we divide this equation by square root of 189 and we get that cosine alpha equals to 9 over square root of 189. So here we subtract, we substitute 189 by 9 times 21 and we get that cosine alpha equals to 9 over square root of 9 times 21. The next step, we'll take 9 out of the root. The square root of 9 is of course 3. So cosine alpha equals to 9. Again, the square root of 9 is 3, so inside the root we left only with 21. So in total we found out that cosine alpha equals to 9 over 3 times square root of 21. Here we divide both the numerator and the denominator of this expression by 3 and we get that cosine alpha equals to 9 over 3 is 3. 3 over 3 is 1, so in the denominator we left only with square root of 21. So in total we found out that cosine alpha equals to 3 over square root of 21. So we would like to turn cosine alpha to express cosine alpha in terms of sinus alpha. So we will use the following trigonometric identity in order to achieve the task. So we have the trigonometric identity T is the abbreviation for trigonometric identity. Let's say that sinus square alpha plus cosine square alpha equals to 1. So here we'll subtract cosine square alpha from this trigonometric identity and get that sinus square alpha equals to 1 minus cosine square alpha. So here we take a root out of this trigonometric identity and get that sinus alpha equals to the square root of 1 minus cosine square alpha. So we found out that cosine alpha equals to 3 over square root of 21. We will square this equation and you get that in this side of the equation we have cosine square alpha equals, we have to square the other side of the equation, so it will 3 over square root of 21 square will be equal to 3 squared, that is 9, over square root of 21 squared, that is 21. So in total we should find out that cosine square alpha equals to 9 over 21. Now we can substitute cosine square alpha in this trigonometric identity by 9 over 21. We will do it now and we will get that sinus alpha equals to the square root of 1 minus cosine square alpha. Cosine square alpha equals to 9 over 21. So today we found out that sinus alpha equals to the square root of 1 minus the square root of 1 minus 9 over 21. So if we succeeded to express cosine alpha in terms of sine alpha. So sinus alpha equals to the square root of 1 minus 9 over 21. So we will multiply 1 by 21 and then we will divide it by 21 in order to overcome the factor of this number. So 21 times 21 is 21 minus 9 over 21. We multiplied 1 by 21 and then we divided by 21, so we change nothing. It is allowable to multiply any point by 1. So today we should find out that sinus alpha equals to the square root of 21 minus 9 is 12 over 21. Here we divide both the numerator and the denominator of this number by 3. You get that 12 over 3 is 4 and 21 over 3 is 7. So in total we should find out that sinus alpha equals to the square root of 4 over 7. Here we take 4 out of the root. The square root of 4 is 2. Inside the root we left only with 7. So in total we should find out that sinus alpha equals to 2 over square root of 7. And we already found out that CB equals to the square root of 112 units in itself. And again, we already found out that CB equals to the square root of 112 units in itself, and sinus alpha equals to 2 over square root of 7. So in the next step, we will implement the law of sines on this triangle, triangle ABC. Repeat quickly on the law of sines. The law of sines is true in any triangle. So actually, this is triangle ABC that could be in any triangle. The length of side AB is C units, side AC equals to B units in itself, side BC equals to A units in itself. This is angle BAC that equals to 8 degrees inside. This is angle ACB that equals to 3 degrees inside, and this is angle ABC that equals to capital B degrees inside. So all the three letters are capital letters. This is capital A, this letter is capital B, and this letter is capital C. And the triangle ABC is described by this circle. The radius of this circle is R. So the law of sines in its full version is as follows. Actually, the law of sines is true for any triangle, even if we are talking about a triangle that is not described by a circle, then according to the law of sines, the following version is true. A over sinus A equals to B over sinus B equals to C over sinus C. So if triangle ABC is not described by a circle, then A over sinus A equals to B over sinus B equals to C over sinus C. And when triangle ABC is described by a circle, like in this drawing, then the following equation is true. This is the full version of the law of sines. A over sinus A equals to B over sinus B equals to C over sinus C equals to 2R. And now is the radius of this circle that blocks triangle ABC. So we use the law of sines in its full version. Because in our drawing, triangle ABC is described by this circle. What is the meaning of triangle ABC that is described by a circle? It means that all the three vertices of the triangle lie in the circle. You can see that A, B, and C lie on the circle itself. For that reason, triangle ABC is described by this circle. So we implement the law of sines in its full version. So according to the law of sines, CB sinus alpha equals to 2R. And R is the radius of this circle that blocks triangle ABC. R is the radius that we are looking for in this question. So according to the law of sines, this triangle ABC, the following equation is true. CB over sinus alpha so CB over sinus alpha equals to 2R. Again, R is the radius of this circle that blocks triangle ABC. So according to the law of sines, in triangle ABC, the following equation is true. CB over sinus alpha equals to 2R. CB is equal to the square root of 112 units over sinus alpha. Sinus alpha equals to 2 over square root of 7. And this equals to 2R. Here we will substitute 112 by 7 times 16. And get that the square root of 16 times 7 over 1 over 2 over square root of 7 equals to 2R. we take 16 out of the root. Here the square root of 16 is 4. So in total this expression equals to 4 times square root of 7. Divided by 1 divided by 2 over square root of 7 equals to 2r. Here we will move square root of 7 to the numerator and 2 to the denominator. And we get that 4 times square root of 7 times square root of 7 over 2 equals to 2r. 4 over 2 is 2, so in total this expression equals to 2 times square root of 7 times square root of 7. And it equals to 2r. Here we have 2 on both sides of this equation, so 2 will get cancelled. And we left only the square root of 7 times square root of 7 is 7 equals to r. So if you found out that the radius that we are looking for in this question, that is the radius of this circle is equal to 7 units in its length. So we finish with the first question. In the next step I will present you the second question and solve the second question of this lecture. In this second question, our task is to find out the area of this semicircle APQB. So in the drawing, we have a semicircle. This is 9 side AC, this is equals to 7 units in itself. This is 9 side PC, this is equals to 21 units in itself. This is 9 side PQ, this is equals to 16 units in itself. This is angle CPQ, that is the right angle. Again, our task is to find out the area of this semicircle APQB. So first of all, we'll define the radius of this semicircle as x. So if the radius is x, it means the diameter AB is 2x. The diameter AB equals to 2x. What is the length of this line segment CB? From the drawing it is very easy to see that CB in total equals to AB minus AC. So CB equals to AB minus AC. CB equals to AB, this is 2x, it is the diameter of the semicircle, minus AC. AC equals to 7 units in itself, according to what is given in the question. So in total we found out that CB equals to 2x minus 7 units in itself. So write it down. CB equals to 2x minus 7 units in itself. The next step, we will complete this semicircle to a circle. So completed the semicircle to a circle. And we'll extend the side PC by straight line until it touches the circle. We define the touching point of the extended side PC with this circle. This point is point M. We define the short line point CM, this short line point CM as A. So here we can implement rule 65. That is about two chords that intersect with each other inside the circle. So repeat quickly on rule 65. First of all, rule 65 is true in any circle. So this circle could be any circle. In any circle, if chord AB intersects with chord CD at point O, then the following equation is true. AO times OB equals to CO times OD. Again, AO times OB equals to CO times OD. So we can implement rule 65 in our drawing. Because in our drawing, this is chord AB that intersects with chord PM at point C. Again, chord AB intersects with chord PM at point C. So, according to rule 65, the following equation is true. AC times CB equals to PC times CM. Again, AC times CB equals to PC times CM. So, write it down. Now, we have chord AB intersects with chord PM at point C. The intersection point of chord AB with chord PM occurs at point C. So all the requirements for rule 65 are satisfied. Therefore, can implement rule 65. According to rule 65, the following equation is true. AC times CB equals to PC times CM. Again, according to rule 65, the following equation is true. AC times CB equals to PC times CM. AC is 7 times CB. CB is 2x minus 7. And it equals to PC. PC is 21 times CM. CM is A according to our definition. So in total, if we found out that 7 times 2x minus 7 equals to 21A. Here we will divide this equation by 7. You get here 7 get cancelled, they left only with 2x minus 7 equals to 21a minus 7, it's 3a. So total if you know the 2x minus 7 equals to 3a. Here we add 7 to this equation. And finally we get the 2x equals to 3a plus 7. In the next step, we join point Q and M together by straight line. By joining points Q and M, we created the right triangle QPM. So this is the right triangle QPM. This is paratriangle MPQ. Paratriangle MPQ, this paratriangle equals to 90 degrees inside and it's subset on chord QM. Therefore, we can implement here rule 5. Click on rule 5. According to rule 5, any paratriangle equals to 90 degrees inside must subtend on the diameter of the circle. In the drawing, we have a circle. This is paratriangle MAN. This equals to 90 degrees inside, and therefore, according to this rule 5, paratriangle MAN must subtend on the diameter of the circle. And indeed, paratriangle MAN subtend on chord MN, that is the diameter of this circle. So according to this rule 5, any paratriangle that equals to 90 degrees inside must subtend on the diameter of the circle. You can definitely implement rule 5 in our drawing. In our drawing, this is paratriangle MPQ. This is equals to 90 degrees inside, and therefore according to rule 5, it must subtend on the diameter of the circle. Paratriangle MPQ subtend on chord QM, and therefore chord QM must be the diameter of the circle according to rule 5. So it is known, this is chord QM, that must be the diameter of the circle according to rule 5. The diameter of the circle is 2x. Why? Because the radius is x, therefore the diameter is 2x. So in the next step, we'll implement the Pythagoras theorem on this green right triangle PQM. Here by PT is the abbreviation for Pythagoras theorem. So in this green right triangle PQM, according to the Pythagoras theorem, the following equation is true. QM squared, this is the square of the hypotenuse, equals to PQ squared plus PM squared. Repeat again, according to the Pythagoras theorem, this green right triangle PQM, the following equation is true. QM squared, that is the square of the hypotenuse, equals to PQ squared plus PM squared. QM, the hypotenuse QM equals to 2x, and therefore QM squared equals to 2x squared. And it equals to PQ squared. PQ is 16, therefore PQ squared is 16 squared, that is 256. plus PM square. PM in total is 20, it equals to 21 plus A. Therefore PM square is 21 plus A square. Okay, PM is equals to PC, that is 21, plus CM, that is A. So total PM equals to 21 plus A. Therefore PM square equals to 21 plus A square. Here we open the brackets on both sides of this, but before that, we only found out that 2x equals to 3a plus 7. X equals to 3a plus 7. If 2x equals to 3a plus 7, it means that 2x squared equals to 3a plus 7 squared. And it equals to 256. Again, if 2x equals to 3a plus 7, it means that 2x squared equals to 3a plus 7 squared. And it equals to 256 plus 21 plus a squared. Now we open the brackets on both sides of this equation and we get that 3a plus 7 squared equals to 3a squared, that is 9a squared, plus 7 squared, that is 49, plus 2 times 3a times 7, 2 times 3a is 6a, 6a times 7 is 42a. And it equals to 256. Plus 21 plus a squared. 21 plus a squared equals to 21 squared, that is 441, plus a squared, plus 2 times 21 times a. 2 times 21 is 42, and 42 times a is 42a. So here we have 42a on both sides of this equation, so 42a will get cancelled. Once I cancel 42a, in this side of the equation, we left only with 9a squared plus 49. And on the other side of the equation, we have 256 plus 441 is 697 plus a squared. So in total, if you know that 9a squared plus 49 equals to 697 plus a squared. Here we subtract a squared from this equation and get that 9a squared minus a squared is 8a squared plus 49 equals to 697. Here we subtract 49 from this equation and you get that 8a squared equals to 697 plus 49 is 648. So total we found out that 8a squared equals to 648. Here we divide this equation by 8 and get that 8a squared over 8 is a squared equals to 648 over 8 is 81. So total we found out that a squared equals to 81. Here we take out all of this equation and finally get that a equals to the square root of 81, that is 9. A equals to 9 units in its time. We already found out that 2x equals to 3a plus 7. X equals to 3a plus 7. So 2x equals to 3a. A is 9, so 3a is 3 times 9, that is 27 plus 7. 27 plus 7 is 34. So in total we found out that 2x equals to 34. Here we divide this equation by 2 and we get that x equals to 34 over 2 is 17. So we found out that the radius of this semicircle x equals to 17 units in its length. Our task is to find out the area of this semicircle. So what is the area of this semicircle? Actually, we know that the area of any semicircle is equal to pi times the radius of the semicircle squared over 2. And therefore, the area of our semicircle, this semicircle, must be equal to pi over 2 times the radius of our semicircle squared. The radius of our semicircle is x. Therefore, the radius squared is x squared. So today we found out that the area of the semicircle, that is the area that we are looking for this question, is equal to pi x squared over 2 square units in size. So it is pi over 2, x is 17, therefore x squared is 17 squared. So today we found out that the area of this semicircle equals to pi over 2 times 17 squared. It is pi over 2, and 17 squared is 289. So today we found out that the area of this semicircle equals to either 289 pi over 2 square units in size, or in terms of numbers, 289 pi over 2 is equal to 453.96 square units in size. Okay, again, we found out that the area of the semicircle equals to either 289 pi over 2 square units in size, or in terms of numbers, the area of the semicircle equals to 453.96 square units in size. So we finished to answer on the second question. In the next step, I will solve the lecture, that is to repeat on the solution of the first question, and then I will repeat on the solution of this second question. In the first question, our task is to find out the radius of this circle. So in the drawing, we have a circle. This is line segment CP. This is equals to 12 units in its length. This is line segment EP. This is equals to 4 units in its length. This is line segment PB. This is equals to 4 units in its length. This is angle CPB. This is equals to 6 degrees inside. Again, our task is to find out the radius of this circle. So it is given as the question that AB is the side line. So if you focus on the upper side of the side line AB at point P, here the sum of the angles must be equal to 180 degrees according to rule 3. Rule 3 states that the sum of the angles on one side of a side line is equal to 180 degrees. So which angles we have at the upper side of the side line AB at point P? We have this angle is equal to 6 degrees in size, plus this missing angle. In total, the sum of those two angles must be equal to 180 degrees according to rule 3. Therefore, this missing angle must be equal to 120 degrees in size. And again, this is the missing angle, CPA, that must be equal to 120 degrees in size according to rule 3. In the next step, we join points C and A together by side line, and we join point C and B together by side line. By doing those two constructions, we get the three triangles. This is the first triangle is the green triangle C. This green triangle CPA. The second triangle is this white triangle CPB, and the third triangle is the big triangle ABC that consists of those two smaller triangles. So in the next step, we implemented the law of cosines on all those three triangles. So we click on the law of cosines. The law of cosines is true in any triangle. So this is triangle ABC. This is triangle ABC that could be any triangle. The length of side AB is A units, side AC equals to B units in itself, side BC equals to C units in itself. This is angle BAC, this is equals to 30 degrees in size, according to our definition. So in this triangle ABC that could be any triangle, the following equation is 2. C square equals to A square plus B square minus 2 times A times B times cosine theta. Again, C square equals to A square plus B square minus 2 times A times B times cosine theta. So, in the first step, we implemented the law of cosines on this main triangle CPA. According to the law of cosines, if we choose angle theta as this angle is equal to 120 degrees inside, then according to the law of cosines, the following equation is 2. CA square equals to AP square plus PC square minus 2 times AP times PC times cosine 120 degrees. Because again, this great triangle CPA, according to the law of cosines, the following equation is 2. CA square equals to AP square plus PC square minus 2 times AP times PC times cosine 120 degrees. So CA is the missing side, so electricity, so it is CA square equals to AP square. AP is 3, therefore AP square is 3 squared, that is 9, plus PC square, plus PC square. PC is 12, therefore PC square is 12 squared, that is 144. So if you found that CA square equals to 9 plus 144, minus 2 times AP is 3 times PC is 12, times cosine 120 degrees. Cosine 120 degrees is equal to minus 1 half. So in total, if you found out that CA square equals to 9 plus 144 is 153. Here we have minus times minus is plus, so this expression in total is a positive expression. We have 2 in the denominator, so 2 get cancelled. After cancel 2, we have only 3 times 12, that is 36. So in total, this expression equals to plus 36. So CA square equals to 153 plus 36. That is 189. CA square equals to 189. Here we took out of this equation and find out that the length of line segment CA or side CA is equal to the square root of 189 units in its length. So this is side CA equals to the square root of 189 units in its length. Likewise, implemented the law of cosines, this right triangle PCB. We chose angle theta as this angle. CPB equals to 6 degrees in its size. So according to the law of cosines, this right triangle CPB, the following equation is 2. CB square equals to CP square plus PB square minus 2 times CP times PB times cosine 6 degrees. And again, this right triangle CPB, according to the law of cosines, the following equation is 2. CB square equals to PB square plus CP square minus 2 times PB times PC times cosine 60 degrees. So CB is the missing side, so this is it, so it is CB square equals to PB square. PB is 4, therefore PB square is 4 squared, that is 16, plus CP square. CP is 12, therefore CP square is 12 squared, that is 144. Times cosine 60 degrees. Cosine 60 degrees is 1 half. So in total, if you found out that CA square equals to 9 plus 144, here we have CB square equals to 16 plus 144, minus 2 times 4 times 12 times 1 half. We have 2 in the denominator, 2 in the denominator, so 2 get cancelled. After cancel 2, we left only with minus 4 times 12, that is minus 48. So in total, if you found out that CB square equals to 116 minus 48, that is 112. CB square equals to 112, and therefore, if we took out of this equation, If I found out that the length of side CB is equals to the square root of 112 units. This is side CB, this is equals to the square root of 112 units in its length. The next step, we define this angle BAC as alpha, and we implemented the law of cosine on this big triangle ABC. We chose angle theta as this angle CAB is equals to alpha. So according to the law of cosines, in this big triangle ABC, the following equation is 2. CB square equals to CA square plus AB square minus 2 times CA times AB times cosine alpha. And again, this big triangle ABC, according to the law of cosines, the following equation is 2. CB square equals to CA square plus AB square minus 2 times CA times AB times cosine alpha. We already found out that CB square equals to 112 and it equals to CA square. CA square is 189 plus AB square. AB in total is AP plus PB. That is to say it is AP that is 3 plus PB that is 4. So in total AB equals to 3 plus 4 that is 7. Therefore AB square equals to 7 squared that is 49. Minus 2 times CA that is square root of 189 times AB that is 7 times cosine alpha. So in total, if you found out that 112 equals to 189 plus 49 minus 2 times square root of 189 times 7 times cosine alpha. So 112 equals to 189 plus 49 is 238. Here we have minus 2 times 7 is minus 14. So in total this expression equals to minus 14 times square root of 189 times cosine alpha. Here we subtracted 112 from this equation. So in this side of the equation we left with nothing, that is to say 0. While on the other side of the equation we have 238 minus 112 is 126 minus 14 times square root of 189 times cosine alpha equals to 0. So here we added 14 times square root of 189 times cosine alpha to this equation. That is to say, we moved this equation to the other side of the equation. And in total, we actually found out that 14 times square root of 189 times cosine alpha equals to 126. So here we divided this equation by 14, so in this side of the equation 14 we get cancelled, and we have to leave with 100, the square root of 189 times cosine alpha equals to 126 over 14 is 9. So in total we found out that the square root of 189 times cosine alpha equals to 9. Here we divided this equation by square root of 189 and found out that cosine alpha equals to 9 over square root of 189. So here we substitute 189 by 9 times 21. In total, if you found out that cosine alpha equals to 9 over square root of 9 times 21. So here we took 9 out of the root, so inside the root we left only with 21. The square root of 9 is 3. So in total, if you found out that cosine alpha equals to 9 over 3 times 21. So here we divided both the numerator and the denominator of this expression by 3. In total, I should have found out that cosine alpha equals to 9 over 3 is 3, and 3 over 3 is 1, so the denominator we left only with square root of 21. So in total, we found out that cosine alpha equals to 3 over square root of 21. See again, found out the 3, that cosine alpha equals to 3 over square root of 21. Here TA is a version for trigonometric identity. We use the following trigonometric identity that says that sin square alpha plus cosine square alpha equals to 1. Here we subtracted cosine square alpha from this trigonometric identity, and finally found out that sin square alpha equals to 1 minus cosine square alpha. Here we took a root out of this equation, and finally found out that sin alpha equals to the square root of 1 minus cosine square alpha. We only found out that cosine alpha equals to 3 over square root of 1. So we scored this equation, and found out that this square is cosine square alpha. We squared also the other side, this side. This side squared is actually 3 squared is 9, and square root of 21 square is 21. So in total, if you found out that cosine square alpha is equals to 9 over 21. And we have the equation that says that sin alpha equals to the square root of 1 minus cosine square alpha. So we can substitute cosine square alpha in this geometric identity by 9 over 21. We did it, and we found out that sin alpha equals to the square root of 1 minus cosine square alpha is 9 over 21. So here we multiply 1 by 21 and then we divide it by 21 in order to have a common factor with this number. So in total we found out that sin alpha equals to 1 times 21 is 21 and divided by 21. So multiply by 21 and divided by 21, so we change nothing. So in total we found out that sin alpha equals to 21 minus 9 over 21. 21 minus 9 is 12 over 21. So divided both the numerator of this number by 3. 12 over 3 is 4 and 21 over 3 is 7. So in total we found out that sin alpha equals to the square root of 4 over 7. Here we took 4 out of the root. The square root of 4 is of course 2. So inside the root we left only with 7. So in total we found out that sin alpha equals to 2 over square root of 7. And we already found out that CB equals to the square root of 112 units in this again. CB equals to the square root of 112 units and sin alpha equals to 2 over square root of 7. The next step, we implemented the law of sines in this big triangle ABC. So I repeat quickly of the law of sines. Actually, the law of sines has two versions. The first version is about triangle ABC that could be any triangle, and the second version is about the same triangle ABC that is inscribed by a circle. And we implemented the full version of the law of sines. That is to say, we implemented the version that said the triangle ABC is inscribed by a circle. The triangle ABC that could be any triangle is inscribed by a circle. This is triangle ABC that could be any triangle. Triangle ABC is inscribed by this circle with radius R. This is angle BAC. This is equal to capital A divided in size. This is angle ACB. This is equal to capital C divided in size. This is angle ABC. This is equal to capital B divided in size. The length of side AB is C. Side A is C equals to B units in strength. Side B is equal to A units in strength. So this triangle ABC that could be any triangle, the following version is to A over sinus A equals to B over sinus B equals to C over sinus C equals to 2R. And R is the result of this circle that draws this triangle ABC. Read again according to the law of sines in its full version. According the following equation is to A over sinus A equals to B over sinus B equals to C over sinus C equals to 2R. And R is the result of this circle that draws triangle ABC. We implement the law of sines in its full version. So, first of all, in the drawing we have triangle ABC that is inscribed by a circle. Why? Because of the fact that all the three vertices lie on the circle itself, it means that triangle ABC is inscribed by a circle. Therefore, we can implement the law of sines of triangle ABC in its full version. That is to say, according to the law of sines, the following in triangle ABC, the following equation is to CB over sinus alpha equals to 2R. Again, CB over sinus alpha equals to 2R, and R is the radius of this circle that draws triangle ABC. R is the radius that we are looking for in this question. So according to the law of sines, we implemented the law of sines in its full version on triangle ABC. The following equation is to CB over sinus alpha equals to 2R, and R is the radius of this circle that blocks triangle ABC. Or triangle ABC is inscribed by this circle. And R is the radius that we are looking for this question. According to the law of sines, in the right triangle ABC, the following equation is 2. CB over sinus alpha equals to 2R. CB is square root of 12. Sinus alpha is 2 over square root of 7 equals to 2R. Here substitute 112 by 16 times 7. So we have square root of 16 times 7 or 1 or 2 over square root of 7. The square root of 16 is 4, so we took 16 out of the root, so inside the root we left only with 7. So this expression total equals to 4 times square root of 7 divided by 1 divided by 2 over square root of 7. Here we moved square root of 7 to the numerator and 2 to the denominator. And if we found out that 4 times square root of 7 times square root of 7 over 2 equals to 2R. 4 over 2 is 2, so this expression equals to 2 times square root of 7 times square root of 7 equals to 2R. We have 2 on both sides of this equation, so 2 get cancelled, and finally found out that square root of 7 times square root of 7, that is 7, equals to R. Or the radius of this circle, that is the radius that we are looking for this equation, is equal to 7 units in its length. So we finish to repeat on the first question, and the next step I repeat on the solution of the second question. In the second question, our task was to find out the area of this semicircle APQB. So the one we have a semicircle. This is the short line segment AC. This equals to 7 inches. This is line segment CP. This equals to 21 inches left. This is line segment PQ. This equals to 16 inches left. This is again CPQ. This is the right angle. Again, our task was to find out the area of this semicircle APQB. So first of all, it is given as a equation. So first of all, we define the radius of this semicircle as x. If the radius is x, it means that the diameter AB is 2x. Therefore, this line segment CB equals to AB minus AC. CB equals to AB minus AC. So CB equals to AB, that is 2x, minus AC, that is 7. So total CB equals to 2x minus 7 units in its length. The next step, we completed this semicircle to a circle. And then we extended side PC by side line until it touches the circle. We define the starting point of the extended line segment PC with this circle. This point is point M. Likewise, we define the short line segment CM as A. The next step, we implemented rule 65 in our drawing. Basically on rule 65, according to rule 65, first of all, rule 65 is true in any circle. So this circle could be any circle. According to this rule 65, if chord AB intersects with chord CD at point O, then the following equation is to AO times OB equals to CO times OD. Again, AO times OB equals to CO times OD. We can definitely implement rule 65 in our drawing. In our drawing, this is chord AB that intersects with chord PM at point C. Again, chord AB intersects with chord PM at point C. So all the requirements for rule 65 are satisfied, and therefore we can implement rule 65. Repeat again. In our drawing, chord AB intersects with chord PM at point C. Therefore, according to rule 65, the following equation is to AC times CB equals to PC times CM. Again, AC times CB equals to PC times CM. AC times CB equals to PC times CM. So this equation is the implementation of rule 65 in our drawing. AC is 7 times CM is 2x minus 7 equals to PC, that is 21, times CM, that is A. So if you don't know that only rule 65, 7 times 2x minus 7 equals to 21 times A. Here we divided this equation by 7. So in this side of the equation, we left only 2x minus 7, and on the other side of the equation, 21 over 7 is 3, so in total this expression equals to 3a. So in total, if you found out that 2x minus 7 equals to 3a. Here we added 7 to this equation, and we found out that 2x equals to 3a plus 7. The next step, we join points Q and M together by side line. By joining points Q and M, we created the right rectangle, triangle PQM. This is a peripherical PQM, or peripherical MPQ. This is peripherical MPQ. Peripherical MPQ equals to 90 degrees inside, and its subset of called MQ. So whenever we have a peripherical that equals to 90 degrees inside, you can implement rule 5. So repeat quickly on rule 5. According to rule 5, any peripherical that is equal to 90 degrees inside must subset on the diameter of the circle. So in the drawing, we have a circle. This is peripherical MAN. This is equal to 90 degrees inside, and therefore according to this rule 5, it must subset on the diameter of the circle. Indeed peripherical MAN, peripherical MAN subset on 4 diameter, that is the diameter of the circle. So according to this rule 5, any peripherical that is equal to 90 degrees inside must subset on the diameter of the circle. You can definitely implement rule 5 in our drawing. If I put in our drawing, we have this is peripherical MPQ that is equal to 90 degrees inside, and therefore according to rule 5, it must subset on the diameter of the circle. Peripherical MPQ subset on chord QM, and therefore chord QM must be the diameter of the circle according to rule 5. Chord QM is the diameter of the circle. But the diameter of the circle is 2x. The radius is x, therefore the diameter is 2x. So QM equals to 2x units in its length. The next step, we implemented the Pythagoras theorem on this green rectangle PMQ. According to the Pythagoras theorem, in a right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Again, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So in this right triangle, again, MPQ, according to the Pythagoras theorem, QM squared, that is the square of the hypotenuse, equals to PQ squared plus PM squared. Repeat again. The right triangle PQM, according to the Pythagoras theorem, the following equation is solved. QM squared, that is the square of the hypotenuse, equals to PQ squared plus PM squared. QM equals to 2x, and therefore QM squared is 2x squared, is equals to PQ squared. PQ is 16, therefore PQ squared is 16 squared, that is 456, plus PM squared. PM total equals to 21 plus 8, therefore PM squared is 21 plus 8 squared. So in total, if you want that 2x squared equals to 256 plus 21 plus 8 squared. We only found out that 2x equals to 3a plus 7. So we substitute 2x by 3a plus 7. If 2x equals to 3a plus 7, it means that 2x squared equals to 3a plus 7 squared, and it equals to 256 plus 21 plus 8 squared. Here we open the brackets on both sides of this equation. And if I found out that 3a plus 7 squared equals to 3a squared, that is 9a squared, plus 7 squared, that is 49, plus 2 times 3a, that is 6a, 6a times 7 is 42a. On the other side of the equation, we have 256 plus 21 plus a squared. 21 plus a squared equals to 21 squared, that is 441, plus a squared minus 2 times 21, that is 42 times a. So it is 42a. Here we have 42a on both sides of this equation, so 42a we get cancelled. After we cancel 42a, this side of the equation we have only 9a squared plus 49, while on the other side of the equation we have 256 plus 441 is equal to 697, and we have here plus a squared. So in total, we found out that 9a squared plus 49 equals to 697 plus a squared. So here we substitute a squared for this equation, so 9a squared minus a squared is 8a squared. 9a squared minus a squared is 8a squared. So we have 8a squared plus 49 equals to 697. Here we substitute 49 for this equation. If I found out that 8a squared equals to 697 minus 49 is 648. So 8a squared equals to 648. Here we divided this equation by 8 and Find further that a squared equals to 648 over 8 is 81. So a squared equals to 81. Here we took out of the equation. Find further that a equals to the square root of 81, that is 9. So a equals to 9. We already found out that 2x minus 3a, 2x equals to 3a plus 7. That is to say 2x equals to 3a. A is 9, so 3a is 3 times 9, that is 27 plus 7. 27 plus 7 is 34. So in total, if you found out the 2x equals to 34. Here we divided this equation by 2 and find out that x equals to 17 units in its length. That is to say, the radius of this semicircle, x equals to 17 units in its length. Our test was to find out the area of this semicircle. Actually, we know that the area of any semicircle equals to pi times the radius of the semicircle squared over 2. Therefore, the area of our semicircle must be equal to pi over 2 times the radius of our circle squared. The radius of our circle is x, therefore the radius squared is x squared. So in total, the area of our semicircle must be equal to pi x squared over 2. X is 17, therefore x squared is 17 squared. So in total, the area of our semicircle must be equal to pi over 2 times 17 squared. 17 squared is 289, therefore the area of our semicircle equals to 289 pi over 2 square units in its size. Or in terms of numbers, the area of this semicircle equals to 453.96 square units in its size. Okay, thank you very much.